Assalamualaikum and good day to Dr. Muhammad Aifaa. My name is Nur Dania, binti Azaman with matric number AE1900066. Today, I will explain about the introduction of our project. Firstly, what is load flow analysis? Load flow analysis is the numerical analysis of the flow of electric power through a network of interconnected systems. When a study is performed on an existing system, it provides insight and recommendations on how to operate the system and optimize control settings in order to achieve maximum capacity while minimizing operating costs. Next, a power flow study employs simplified notations such as one-line diagram and a per-unit system, and it focuses on various aspects of alternating current power parameters such as current and voltage angles as well as real and reactive power. Next, the study of flow consists of 3 steps. First step is modeling of power system components and networks. Next, development of load flow equation. And last step is solving the load flow equation using numerical techniques. Next, our project objective consists of 3 objectives. Firstly, our objective is to analyze the system operating condition using power flow analysis based on Gauss-Seidel and Newton-Raphson methods. Our second objective is to propose a power flow analysis solution that facilitates the operation of the future grid. And lastly, our objective is to determine the best method to be used in system condition that using power flow analysis. Next, our project scope is we choose 19 machine benchmark as our test system for this project. It is because it enables access to the performance of the power flow technique via a variety of iterative methods. That's all from me. Thank you.
Hi, my name is Nur Hidayah Najwa binti Sharudin and my matric number is AE19003. This is the methodology. These are methods and software used: Gauss-Seidel method, Newton-Raphson method, and MATLAB Simulink software. Gauss-Seidel method and Newton-Raphson method are the most common used method in order to solve problem in power flow analysis. Next is the flowchart of project. First, we start with find information related to 19 machine benchmark system and power flow analysis. Then we compute the mathematical formula of the problem. Next, we simulate using MATLAB Simulink software. After that, we check if we get an error, we need to compute the mathematical formula of the problem again. If not, we will start to compare the result obtained between Gauss-Seidel method and Newton-Raphson method. After we get the comparison, we will start writing report and analysis of the system. And then, the end. This is the conclusion of the project. The 2 widely used methods to solve power system analysis problem are Gauss-Seidel method and Newton-Raphson method. For this project, both methods chosen, which are Gauss-Seidel method and Newton-Raphson method, were used to analyze the system operating condition, which the system chosen is 19 machine benchmark. From the results obtained, there are differences between both Gauss-Seidel method and Newton-Raphson method from computation time, number of iterations, and complexity of implementation. As a conclusion, it is proven that both Gauss-Seidel method and Newton-Raphson method are suitable to test and analyze the system operating condition. Thank you.
Assalamualaikum warahmatullahi wabarakatuh to Dr. Aifaa. My name is Siti Nurlina binti Azmi. My matrix number is BE20703. Now I am going to explain a bit about the simulation and the result obtained for our test system, that is 90 machine benchmark. Okay, first, the method that we use to solve this problem are Gauss-Seidel method and Newton-Raphson method. For the Gauss-Seidel method, we use the coding from Hadisada toolbox, while for the Newton-Raphson method, we use from PST software. Okay, for the Gauss-Seidel method, the data that we use are from the PST software, which from here we use the D19J new. After we run the simulation, the result will print out like this. The elapsed time for Gauss-Seidel method is 6.779573 seconds. The number of iteration is 101. So this is the load flow of the system, and this is the line flow and losses of the system for Gauss-Seidel method, right? Okay, now for Newton-Raphson method, I use the coding from PST software, which I got from the folder PST v3, and just simply copy and paste it into the MATLAB simulation. This is the coding, and after we run, I use the data, the same data as I use in Gauss-Seidel method, which are D19J new. Okay. Next. Why? Alright. So the result will shows the real power losses and the total reactive power losses for the system and the line flow. Alright. For Newton-Raphson method, the number of iteration is 4, while the solution time is 0.014 seconds, which means Newton-Raphson method are more simple but complex compared to the Gauss-Seidel method. The number of iteration is also less than the number of iteration for Gauss-Seidel method, which are 101. Right. So this shows that the Newton-Raphson method are more simple compared to the Gauss-Seidel method. Thank you.
So for the discussion, we are needed to assess the performance of the power flow technique of the system. For this project, we are using two methods, which is Newton-Raphson method and Gauss-Seidel method. Newton-Raphson method is a technique to determine the root of real value function. The inventor of this method are Isaac Newton and Joseph Raphson. We begin this method with a single variable function defined for a real variable, its derivative, and an initial guess for a root of f. The function is valid if all the assumptions are met. The advantages of this method that this is one of the most rapid root converge. It is also easy to convert to multiple dimensions, and the results are also accurate. There is also some disadvantages of using this method, such as this method converges slowly if there is a lot of multiple roots. Symbolic derivative might require, and also inflection point might happen. Next method is Gauss-Seidel method. So what is Gauss-Seidel method? Okay, it is an iterative approach for solving an n-dimensional linear equation with unknown variable. The inventor of this method are Carl Friedrich Gauss and Philipp Ludwig Seidel. The Gauss-Seidel technique converges if the number of roots inside the unit circle equals to the order of the iteration matrix. This method also very similar to Jacobi's method, but the difference is the Jacobis employs value from the previous step, while Gauss Seidel uses the most updated value. The advantages of using this method that it is easy to program and it takes up less memory than new Refson method. But the disadvantages is if the large number of the iteration, the converge rate is slow.